All right, so now we're going to look at an example where we are going to find the area of the region bounded by two functions of y. So we are not going to integrate with respect to x. So at first, it's going to kind of seem weird to do, but it's actually pretty much the same process as you would do when you're integrating with respect to x, but you have to look at it from a different perspective. So like, let's look at this example. So here we have the equations x equals 3 minus y squared and x equals y plus 1. So these are functions of y. So I'm going to write this as f of y. That'll be I'll make f of y equal to 3 minus y squared. And then let's make g of y be equal to y plus 1. So we got to figure out what area is bounded by them. So this is a parabola. It's a parabola, has an intercept of 3, and it's going to be concave down. But remember, it's in terms of y. So you want to kind of look at your axes like this. It'll intersect the x-axis at 3, and it'll be going downward like that. Let me try to draw my best parabola. It's okay, I guess. That's your function f. And g of y is a straight line as well, but the y-intercept is 1, but the x-intercept is 1. So it'll be oriented like in this direction. And again, you can always just plug in numbers and check to make sure if you're a little rusty on this stuff. But when you first do these, I mean, I'll admit I get confused too sometimes, because the y-axis runs the other direction, because the negative y values are on the right and the positive y values are on the left. So you're going to see how that is going to affect how you're going to integrate. So let's look at the region that we're trying to find the area of. So it's going to be this shaded region in here. So first we have to find the points of intersections. We got to find that point and that point. So like usual, we're going to set each equation equal to one another and solve for the y value. So we're going to have 3 minus y squared is equal to y plus 1. Add y squared, take away 3. We get 0 equals y squared plus y minus 2. 0 is y plus 2 times y minus 1. And so your y-intercepts, or your solutions for this would be y equals -2 and y equals 1. So now we have to find the x-coordinates. Technically we don't, but let's just find it just because, it'll make our graph much more complete. So plug -2 into either equation and find x. So -2 into this, -2 plus 1, we'll get x is -1. So we have 1 point at -1, a common -2. Plug y equals 1 for the other point. So we'll get y plus 1 plus 1, we'll get x is 2. So the coordinates of the other point will be a 2, 1. And so this would be the 2, 1. And then this will be the -1, -2. All right, so now we have to figure out how we're going to set up our integral. So the area of the region will be equal to, well, all you really have to do is, interpret your areas from this perspective. So from here, you can see that the parabola is going to be on top on the entire interval. So we're going to have f of y minus g of y. And again, it's oriented, the axis runs in the other direction. because the y values are negative here and positive here. So we're going to integrate from -2 to 1 because we're integrating with respect to y. So the area will be from -2 to 1, and we'll have f of y minus g of y. Now you're probably first wondering, or if you probably really realize why, like why would we even want to integrate with respect to y? And you know, why not just go straight to x? Well, you can probably see now that this region doesn't have one of the functions that's always going to be greater on any interval. Well, first off, these aren't even going to be functions of x. That's already an issue. So I'm going to show you another way to do it, but it's actually going to involve more steps in part B. But let's first look at this. Like here, you can see that f is on top of g here, but f is also below of g here. So there's no like greater function there. Only here there is, but f is above and below. So it's actually like going to be more complicated to integrate with respect to x. It still can be done, but it's just going to take a lot more work. So integrating with respect to y actually is easier. It may be a little confusing that when you first try these, but it's actually going to be easier because it's just f of y minus g of y. So then let's go ahead, let's set up our integral. This will be f of y will be the 3 minus y squared minus g of y, the y plus 1 dy. Working our way down. So let's go in standard form. So negative y squared minus y, 3 minus a 1, so plus 2. dy. So antiderivatives, negative y to the third over 3 minus y squared over 2 plus 2y from -2 to 1. And then see from here, it just becomes pretty much not even a calculus problem here. It's just an algebra problem. But once you set the integral properly, the rest is nothing new from what you've been doing the last couple chapters. Let's just make sure though that we don't mess up, because sometimes it's gonna be a little annoying to mess up on the algebra part. So we go from, we're gonna plug in the 1 still. So it still works out like that. That's still your b. Plug in 1 and then plug in the 2. So negative 1/3 minus 1/2 plus 2 times 1, or just plus 2, minus, now we plug in -2. So -2 cubed, -8, -1 to -8 times -1 will just be 8. 8 over 3, negative, so -4. Or not really, but -4 over 2. Plus a 2 times -2, so we can just say plus a 4. Or -4. -4. And this is, again, we just got to make sure we don't mess up on our arithmetic. Put these all over 6's. -2 6's minus 3 6 plus 12 6. Minus 16 6 minus, that's just 2, so that would just be 12 6 minus 24 6. I always like to show all my work in these ones because I get paranoid that I'm going to mess up somehow, and You know, that's annoying, especially on a test. And 6 fractions in like denominators of 6 occur a lot for some reason, I've noticed. All right, now we just add. So we got 7, 6 minus 2, 4, negative 26. And then we'll get 27, 6. Or 4.5. Let's say 4.5 units squared if we want. All right, so there you go. That region will have an area of 4.5 square units. So in the next video, I'm going to go over how we integrate and find this area by setting up an integral with respect to x. So good luck.